Hello, everyone.
Hello. Is it okay to listen my voice?
Yes, and do you hear me?
Yes, great.
Yeah,
No problem. Okay. Hello, Professor Batikus. Good to see you.
Good morning.
Good morning.
Hi.
Good afternoon.
Yeah.
How about the situation? Is it good?
So a long time ago, we didn't see each other.
Yeah, right. Do you have any plan to participate the South Conference, Milan?
Which conference?
South Conference, Milan, this September.
No, we didn't have a chance this time.
Okay.
Do not have a chance.
I think you have some trouble because of the war between Russia and Ukraine.
Yeah, it is actually, but still, after this COVID and war, we had a lot of meetings which were postponed, and now we have a lot of meetings. And as you recognize, it was not so easy to handle this meeting time. So a lot of things going around. And
Okay.
And how about you? And how about Korea, South Korea?
There is no particular one in South Korea, but nowadays we are worried that COVID is quite increasing. That the third wave, people says that that's third wave, fourth wave. That's my concern. But the current COVID variant is not a big deal, I think.
Mm-hmm.
It's quite similar, the common cold.
Okay, we have the same. Of course, Europe has the same issue, and it seems that it's starting already to increase. So in September, I think it will be quite huge amount of this increase. But what I hear from my colleagues, I have few colleagues that already got this new COVID now, and it is not so hard. So it's more like soft COVID form.
Okay. Do you have any restriction nowadays?
No, actually, no. There is no restriction in Lithuania. During the summer, a lot of people have holidays, so it is like not so many restrictions at all. Now it's not any restrictions at all, actually. But now they started to talk about that we have to come back, and but we had some meetings in Italy, so it is already the obligation to wear a mask and etc. So it depends on country very much.
Actually, I visited the United States, Chicago, last month.
Mm-hmm.
They also have no restriction, any other things. Yeah. No mandatory of mask. No obstacles to enter into the United States. It sounds good. It looks good.
Okay.
Anyway, I appreciate you for giving this chance to communicate with each other. Thank you so much for that.
And thank you for the invitation.
Okay, I think we can start the meetings.
Okay, so
which one do you prefer?
Maybe we can share the agenda and briefly to go through the agenda, and then we will start. Okay.
Dr. Skulteke, would you share the agenda of this?
I can share agenda.
Okay, thank you so much.
Can you see now agenda?
Yes, it's perfect.
Okay. Okay. So we have 3 questions today, yes, and in the beginning we will have presentation from our side, from Vilnius Tech University and the Road Research Institute. So some slides about general information, and afterwards about experience what we had in the few past years when we were developing, and we had a project regarding modular payments, and it was oriented to mixture development, and afterwards we had some test sections with pedestrian pathways, and also some information about roller compacted concrete, which we introduced 4 years ago with some companies in Lithuania, and now the amount of these payments is growing up. So afterwards, 40 minutes from your side, so short presentation of Korean Express Corporation and challenges for tax Korea Expressway Corporation and road construction. So, and as we saw already in presentation about also about modular payments. And so finally, some discussion.
Okay, great.
So we are fine with this agenda. If you have any additional comments or proposals, so you are free to go ahead now.
No, nothing else. It's topic, I think.
Okay. So if it is okay, so we can start the presentation of Road Research Institute and what activities we have in this institute.
Okay, please do that.
Okay, thank you. Okay, can you see the slides?
Yes.
Okay. So activities and research area. So today, actually, just few sentences about us. So today we are attending 2 people from Road Research Institute. So Judita Gražulytė, she is the chief scientist and PhD, and we participate in a lot of activities. And I'm Audrius Vaitkus, head of this Road Research Institute and also professor in Road Department. And today we are only 2 due to a lot of activities in the institute now, and also we have few main people in holidays, and also we have some, as I already mentioned, COVID situation. So today we are 2, but if it will be any questions which cannot be answered by us, so we will come back with these answers later. So some facts and history. So the history started in 1922, when Department of Roads was developed in some other university. Then our university was transferred from Kaunas city to Vilnius city, to the capital. And finally, in 1999, Road Research Laboratory was established. And finally, based on Road Research Laboratory in 2009, Road Research Institute was established, and we are performing in road research activities till now. We are developing some research areas and etc. So some facts about our university. So this is a 3rd university regarding students in Lithuania, and regarding amount of students, and this is only 2 technical universities in Lithuania. So we are one of these technical universities, and 8,400 students. The number is decreasing. Some 10 years ago we had almost twice students, but as every year requirements for students is increased, and the students, the school absolvents do not want to go to engineering studies, so it's an issue in all world, and we have decreasing number in students every year. But now it's quite stable, and it is about 8,000-9,000. So composition of Road Research Institute, now we are about 40 people, and 12 of them are PhDs, and 3 are PhD candidates. Also, we involve very much students in our activities, and we have 10 students of different grades, starting from first course, when they come to university, and finally, also during PhD study period, we employ students, and we pay salary, and they provide quite a lot of activities for us also. So our annual turnover is about 1 million, and the institute is like a small company of university. So we have to earn money to pay the salaries for researchers and chief specialists and engineers and in the laboratory. So we have accredited laboratory, and we're trying to be active in international projects. So the main activities: national and international research and feasibility studies, laboratory testing of building materials and transport communications, road safety audits, very important part of our activities. And now we have a project in Georgia country, and we have missions which are related to transfer of knowledge about road safety and trauma register. So we have forensic expertise, and we have a lot of issues when they need special forensic expertise related to some problems in roads and in pavement structures, etc., etc. So we have such experts which can be allocated by the court, selected by the court. So we provide consultations. We do a lot of design of pavement structures with mechanical and peer pavement design methods. And for example, in Lithuanian Road Administration, they have more than 80 technical documents which regulate design, safety issues, pavement design, materials, asphalt, concrete, etc., etc. And a lot of these documents were prepared by our university. And of course, training courses for specialists which are involved in the communication, roads and transport communication infrastructure design, maintenance, and construction. So research areas for an open road, it's quite well-known concept which came from Federal Association, intelligent road building materials, developing new materials, stiffer materials, noise-reducing materials, same price, but better quality materials. Then very interesting and very important topic about turning waste into a resource for road construction and maintenance. Of course, circular economy, CO2 reduction of CO2 emissions, and some intelligent engineering measures for road safety. And it was said that we are about 40 members of our team, but we have a lot of different departments in university, and we provide a lot of connected activities. For example, with buildings department, bridge department, and also environmental issues department, and geodesy, etc., etc. So we have a lot of connected activities with other departments in university. And we introduced a few slides about our last research project. As from last 5 years, we had 3 plants which burn municipal waste, and it generates MSWA bottom ash. So it seems that we already have about 150,000 tons per year, the aggregate, which comes from burning the municipal house waste and getting the electricity and also the heat for for house heating. And then we have this product which can go to Judita, to šiukšlynai.
Landfills.
It should be moved to landfills, but it's not very efficient. And we're starting from some 2016, 17, we started a lot of research projects about the possible use of this bottom ash in road construction. So here you can see some pictures from Klaipėda city, which is very near by Baltic Sea. So here is a Klaipėda city, and you can see that it is like three big regions in Lithuania and three these plants which burn this waste. And the first was in Klaipėda, and now we have in Kaunas and in Vilnius, and these two pictures are from Klaipėda and Kaunas. And you can see like this is like a aggregate, like a normal aggregate, but a little bit different characteristics of, for example, if we compare to dolomite aggregate or granite aggregate. So after our research, it's already stated and that it can be used in lower part of the pavement structure, so in some sub-base layers. And now we are we are doing some research about possible usage in base layers and even in asphalt concrete. So in 2021, it was started the project by Lithuanian Road Administration, and the road was built with this house waste bottom ash, MSVE bottom ash. And here we had different pavement structures with a section length of 200 meters, and in general it was 1 kilometer. We installed some sensors, etc., and we have different combinations. For example, all the subbase and bases from MSVE bottom ash, and in other cases we have only subbase and the bases with the mixture of natural aggregate and 30% and 70% of the ash. So another research project which is important for us due to the recycling of used tires is chrome rubber modified asphalt mixture, and we have some PhDs regarding this and also ongoing postdoctoral research. So to use user tires, the rubber from user tires for asphalt modification and to replace the costly polymers and to get the same or quite similar characteristics. So in 2020, just beside our institute, we made some test section when the stone mastic asphalt was modified by chrome rubber. And we see that the exploitation of that sector is very sufficient, and it can be very easily compared to polymer modified bitumens. Another important issue is noise mitigation, and from 2014 we developed quite a lot of mixtures related to noise reduction. So here you can see our measuring device, so CPX, when we can measure by close proximity method the tire and pavement surface noise levels. So and the last initiative comes from business, and we have the design project in Vilnius city, where some cross sections will be rebuilt, and in one section we have very big, very high level of longitudinal slope, And in some sections about 70-100 meters, where is needed to secure that during winter time the pavement will be not so slippery, and the buses which goes in that so if we can say some elevation or hill wouldn't slide beside to side of the road. So now we starting discussion with designers and also with some companies. We will have meeting on Friday how to deal with that section and how it can be installed the icing system based on geothermal energy. So, and this is how we look. And thank you very much for this opportunity to present our activities. And if you have any general questions regarding the university, Vilnius Tech or Road Research Institute, so please go ahead. And
thank you so much. Let's have the questions after our presentation.
Okay, thank you. So now we will go to another part.
Yeah.
Presentation, and we will start with modular pavements, and Judita will present that part about modular pavements, and I will join her presentation with roller compacted concrete.
So as was presented, now we will talk about our experience in modular pavements. So as it was mentioned, we had a huge project in 2017, and it lasted 3.5 years. And this project was focused on modular pavements. And the aim of the project was to expand the applied knowledge that is essential to the development and commercialization of modular pavements. So the main concept of modular pavements is that these pavements are precasted in the plant, and the prepared slabs are transported to the project site only after the curing period. So it means when the desirable concrete strength is achieved, and these slabs are installed on the prepared foundation. Modular pavements typically also are known and are named as precast concrete pavements. So you will see in our presentation that sometimes we are using the abbreviation as it is PCP, and it stands for precast concrete pavements. Concrete modular pavements are superior to typical pavements because they are fast constructed and they can be fast repaired. Typically, the works are done during the night, so from about 8 p.m. up to 6 a.m. And this means that traffic congestion is reduced to the minimum because the whole road shouldn't be closed, and of course the traffic volume is much lower. Also, slabs prefabrication in a plant results in better concrete quality because we can control it better, and we can control the curing conditions, what is also very important for the final product. When we produce modular pavements, modules, we practically eliminate the risk of material segregation, and this segregation is very relevant and important for asphalt pavements when we transport the materials. So that in modular pavement case, we produce slabs in the plant. So it means we don't need to transport all these materials, and we eliminate this risk. The other advantage is that these pavements we can construct in chilly weather and during a light rain, and it's very significant in East and North Europe, where the weather conditions is not so good, and we have very short period, for example, for asphalt pavements constructions. And one more advantage is that modular pavements typically can have lower thickness comparing to typical concrete pavements, and this is achieved by ensuring very good quality of the final product. In general, three types of concrete modular pavements exist. So the first one is precast prestressed concrete pavement. The second one is jointed precast concrete pavement. And the last one is incrementally connected precast concrete pavement. We will discuss all these three types a little bit later in more details. But what I want to say that all types of these pavements can be used to construct new pavements and to repair existing cast in place or even precast concrete pavements. So let's get back to all those three types. As I mentioned, the first one is precast prestressed concrete pavements. This pavement consists of wide and quite short panels, which are post tensioned together in the longitudinal direction on the project side in order to form an effectively jointless slab. Each separate slab is prestressed in the transverse direction during the fabrication, and the width of the panel is usually equal to the full width of all traffic lanes, and of course shoulders if it needs to be constructed. The length of the panel varies from 2.5 to 4.3 meters. What I like to say that this number is very rarely used, and most test sections were constructed at the beginning of the development of modular pavements. The second one and the most popular type of modular pavements is jointed precast concrete pavement. In this case, slabs are reinforced or prestressed in a plan during slabs fabrication. The width of each slab is typically equal to the width of one traffic lane, and the length of the slab varies from 1.8 to 5.5 meters. All slabs together are connected on the project side by using different systems of dowel bars and slots. Typically, these systems with dowel bars and slots have to ensure that the load is transferred between the slabs. It is known that at least 11 different systems based on this concept are developed. And the main difference between these systems are the techniques that are used to connect the adjacent slabs and to level the slabs. Now we will look more deeply in some of these systems, how they differ, what are the main characters, aspects, and etc. So the first one, I would say the most known system is Fort Miller Super Slab system. This system was developed in New York. The precast slab are constructed on a thin layer of bedding layer, which is placed over existing subbies. In this system, dowel bars, tie bars, and slots are cast into the bottom of each slab. This position, so that dowel bars and slots are cast into the bottom of each slab, keeps grout on the bottom and protect it from negative effect of freezing and thawing. As well, it protects from the de-icing chemicals. A special method with two grout ports, you can see them here. A special method with these two grout boards are designed in order it would be easier to pour the grout that fills the slot and ensures that there are no air between dowel bar and slot. The second system is a quick slab system. This system consists of patented quick joint steel couplers, which interlock reinforced precast slabs, allowing reinforcement continually throughout the length of the connected sections. The main drawback of this system is that the length of the adjacent slabs are limited and expansion joints between connected sections have to be installed. The third system is from the Netherlands. The main difference from other systems is that slabs are not connected with dowel bars. Instead of that, they are placed on precast reinforced concrete piles with cross beams and connected with them using pre-stressed anchors. However, slabs can be also constructed on grade support. In this case, the load transfer between adjacent slabs has to be ensured. In modular slab system, slabs are constructed of a reinforced concrete layer covered with two porous concrete layers. The upper layer of porous concrete is fine-grained, while the bottom layer is coarse-grained. This composition enables to reduce the tire pavement noise, and slabs are typically manufactured upside down in order to guarantee a very even surface. Also, if there is a need, the multi-slab system can also contain a pipeline system to control the temperature of the slabs. One more system is prime system. This system is unique because of hexagonal shaped slabs. The joints between slabs are filled with waterproof polymeric material. In this case, slabs are mechanically independent. Otherwise, concrete connection keys are used to connect adjacent slabs. And in this case, joints are filled with fine-grained sand. In this case, when we are using the filling material and it is fine-grained sand, pavement is built in successive line, progressing from one edge to another, and slabs are interlocked to each other. This interlocking enables to transfer some level of load at the joints and leads to smaller slab size. And last, the system which I would like to present is from the project Hester and its Germany practice. These slabs are reinforced with top and bottom laths, and this section is constructed at vast test sections where we are testing different pavement structures. And as you can see, mobile load simulator is used to simulate axle loads and apply a defined mechanical load in the joint. To connect the slabs, dowels were used and foam was spread below the slab. The consistency of the foam is very important since at the first tries to install these slabs, the foam was too viscous, it was too dense, and actually the foam should be very liquid. It should look like the water. And then the composition of the foam was changed. It was successfully installed. And last type of precast pre-stressed concrete precast pavements is incrementally connected precast concrete pavements. In this case, slabs are either reinforced or pre-stressed. The width of each slab is equal to the width of one traffic lane, and the length varies from 0.5 4.6 to 9.1 deformed bars are used to connect the slabs, and they are also lock the connected joint and enables the load transfer across joint. And the active joints are constructed only between sections. This method is more like theoretical one. In practice, it's rarely used, and it's hard to identify in which sections it's actually when practice used. And now we will talk a little bit about the support of the slabs, because it's very important, and a strong and uniform slab support is actually a key to successful pavement performance. So in general, 3 types of support exist. So grade support, grout support, and piles and beam support. In the case of grade support, a bedding layer typically is placed on the existing pavement. In the grout support case, are used leveling boards or shims, and the gap under the slab are filled with a high-strength bedding grout. In some cases, there can be used urethane grout, for example, polyurethane foam materials, and in these cases, there is no need for leveling boards and strims. You just need to pour the foam under the slab, and it will expand and lift the slab to the desired position. And in this case, is provide uniform seating of the slab over the existing base. In the last type of the support, I used piles and beams on which slabs are constructed. The support type is reasonable in areas where the existing base is unstable and all other systems are not suitable or too expensive. Now let's see a little bit our test sections with modular slabs. As it was mentioned, most our test sections are pedestrian paths. Here is a short video how we have constructed it. Do you see it? Yeah. Okay.
Yes, it's okay.
Yeah. So as you can see, the slabs were produced at the plant when were transferred to the project site. Actually, the site is near our institute, so we have a nice sidewalk on the existing pavement. Where put a bedding layer, and on that bedding layer, the slabs were constructed. You can see here a machine, a vacuum machine, which helped to lift the slabs and transport to the position. After the construction, we made different measurements. We measured texture because we designed different types of the texture by using different surfaces. And here is our pathway from different modules. So shortly about this. As I said, this pathway is near our institute and it was constructed in 2019. Slab dimensions is 1 meters length, 1.5 meters width, and 5 centimeters for the thickness. The slabs were without reinforcement, and the total length of the path is 21 meters. And we have 4 different pavement structures. So the smooth surface, smooth textures, rough texture, and texture achieved as a result of exposed aggregate concrete usage. And these textures were achieved by using different texture map. We also used two different agents to achieve red color, so it was powder and liquid pigments. The slabs were produced from typical concrete mixture with synthetic micro and macro fibers. So these fibers were added later, and 20 slabs were produced with these mixtures, and one slab were produced from exposed aggregate concrete, which was developed at our laboratory. As I mentioned, all slabs are without reinforcement, and joints between two slabs were filled with granite screenings. Here you can see the current condition. Actually, we have some cracks, and it shows that the thickness of 5 centimeters is not enough when we are keeping in mind these dimensions of the slab, and that there is no reinforcement. Also, we have some scaling and pop-outs, and they are mostly related to the winter maintenance, because we are using dyes and chemicals, and of course it's a result of freezing and thawing cycles, which are quite often in Lithuania. I'd also like to show what problems we faced during slab production. So one of the main problems was non-uniform compaction of concrete mixture. We also had too high deviations of thickness from the design guidelines. So in some cases, we had even less than 5 centimeters, and there were too high water-cement ratio. And all of these problems actually can be solved by precise production quality control. Actually, it was our first trial, and we had a company who produced these slabs, and it seems that they didn't believe in our project, and probably that's why we had these problems. The second, our test site is pedestrian path in other street of Vilnius. This pedestrian path was constructed in 2020. The slab's dimensions is the length is 1 meter, the width is 1.8 meters, and the thickness this time is 6.5 centimeters. The whole length is 22 meters, and the all texture is the same, and it was produced with concrete mixture with exposure class of XF4. It means that it should be resistant to freezing and thawing, and chemicals that are used for de-icing, and all slabs were reinforced with 2 mats, top and bottom. And actually, it seems that it worked quite well. Here is the pavement structure, and joints between two adjacent slabs were filled with granite screenings. And for this pedestrian path, we also used municipal solid waste incinerator bottom ash, which were presented earlier. So here are all our publications that were delivered during the implementation of the project. We also have some patents. Most of them are for the designed concrete mixtures, and one patent is submitted to the European Patent Bureau. Here are our main findings and recommendations for further research. So I will go very fast for them, since we have other presentations. So in general, as I mentioned, that the most popular type of precast pavements is jointed precast concrete pavements, and then can be used both for repairs and continuous construction. During our project, we identified the most important issues and challenges related to modular pavements that have to be addressed in the future. So here you can see that it's fabrication of slabs, assurance of uniform support. Very important is the connection of the slabs and etc. Here we used the existing calculation methods and determined the optimal dimensions of the slab in this specific case. And it was determined that seeking to decrease the thickness of slab, high performance concrete mixture had to be used, and later we developed this kind of mixture that helped to reduce the thickness of the slab. Also, we tried to produce slabs with municipal solid waste incinerator bottom ash, and it resulted that we can replace up to all coarse aggregate. We also developed exposed aggregate concretes for sidewalks and for highways. And it is recommended to use a negative retarder when we are preparing exposed aggregate concrete elements. Also, we checked if silica fume is worth to use, and it seems that 7% is the optimal content, and the use of both fibers of silica fume leads to the best mixture performance. We later developed the mixture, which has both these elements, and the use of this mixture results in the reduction of the thickness from 322 millimeters to 200 millimeters if it's a bound-based course. And the last our recommendation and finding is that the 6.5 centimeters thick concrete slabs with top and bottom reinforcement can be successfully used to construct pedestrian and bicycle paths and sidewalks. So that's all from the modular pavements topic. And now we are going forward to discuss about roller compacted concrete. Maybe you would like to share my...
Yeah, I will share by myself, okay?
Okay.
If you could stop sharing.
So you are going to share?
Yes, I will share.
Okay, sorry, yeah, fine.
Okay, can you hear me properly? No? Okay, so roller compacted concrete, as we started to use it some 5 years ago in Lithuania, and it comes from the history. It was developed some almost 40 years ago in the United States. Afterwards, it was done quite a lot of improvement in composition and possible usage areas, etc. But dealing about the differences of the roller compact concrete and regular concrete, conventional concrete, you can see here from the graph that in roller compacted concrete we have less water, more fine aggregates, less crushed aggregate, and less cement. But we can reach the same characteristics, the same strength, compression, and flexural strength as the conventional concrete mixture. So the possible usage is containers, terminals, seaports, airport aprons, roads and streets, and also it can be used as a base layer for highways when we use joint plane concrete pavements. It can be used as a base layer. So some advantages and disadvantages. So fast construction, economical, long life, ability to withstand high stresses and high bearing capacity. So quite a lot of advantages, but some disadvantages that it is some additional requirements for concrete plant. To get a very good composition of a mixture, very precise organization of work is required, as you should do quite a lot of things in very short time to deliver the concrete on site, to lay down and to compact during 1 or 1.5 hours. So, and smoothness and aesthetic appearance, sometimes it's not the same quality as joint plain concrete pavement when we use the slipping form paver. So the typical structure, here you can see that it was developed pavement structure with stabilized base layer. So there is no regular unbound base layer, and we developed the pavement structure which is we do not need to do a lot of soil replacement, so it is cost efficient. Then we can use the same soil which is on site, and we have to stabilize. And you can see that it is 2 layers of stabilized soil, but it's with different characteristics. One is 20 centimeters. If we deal about bearing capacity, there is no need to use this 20 centimeters of subbase. But still, in our country, we have quite big challenge during winter time. We have quite low temperatures, and this is to secure that the pavement structure will be stable due to the frost effect. We have to secure the minimum thickness of pavement structure due to the frost activities. So this subbase layer is less stiff than upper base layer, and this is how it looks pavement structure. And above we have the roller compacted concrete. So this is there is no mark, but it's 37 compression strength, and you can see that environmental effect classes is quite high. So XF4 is related to de-icing salt and freezing effect distance, 60 centimeters. This is like an example for quite heavy crowded road or area, and how it looks on site. You can see the stabilization, the cement, some additional preparats, also some additives. So cement, water, and intermixing everything, and then compacting. So it will be base layer. So how it looks like after compaction. And finally, the laying down the roller compacted concrete on top. So you can see it's look like regular asphalt paver, but it's with high density, high amplitude, and high frequency compactor. So after the paver, we get quite a high level of compaction, 95%, and afterwards we have to compact with the roller till 98%. So starting from 2006, the first section was like in the private territory, private road, and this is the combination. We use different thickness, starting from 10 to 60 centimeters, and only 30 centimeters of stabilization. And after 8 years, the road is good shape and good condition. Another project is for pedestrian pathway by the in the Kaunas city by the Neris river. And in 2021, we started with very crowded areas, so with high stress pavements, so a lot of heavy vehicles. And you can see here is 17 centimeters of roller compacted concrete. Each time we calculate what the minimum thickness is needed to carry out about heavy loads, and another project for military purposes. And we already had almost almost 2 years of monitoring of this road, and it is in very good condition. Even tanks are using this road. Also, another military project in another military small city, we can call it like it, and also in previous time we used a lot of also precast concrete plates, but it was not in a very good aesthetical view, and also they have quite wide joints, so there's no very convenient to go on that type of payment. And now militarians want to have a lot of these roller compacted concrete pavements, and they like them very much. So the last activities in this year. So some companies has very good concrete mixing machines, and the best quality we get when we produce concrete mixture on site, so very close to the construction site, because we have to mix to deliver on site and to compact for 1.5 hours. So this is quite short time. Of course, we can use some additives which can expand the time for laying down and compacting the layer, but still it is very efficient, and you have a mixed plant on site. Here is some examples of teapot containers, and just after 5 days, this pavement structure was loaded by these containers and has no any problems. So this is a comparison, and it is more comparison about not about roller compacted concrete, but more about pavement structures when we have stabilized these layers, and we stabilize existing layers with cement and some special additives, and we get a very good bearing capacity. And here is a deflection measured by 40 meters per 2 meter, and here is a pavement structure with roller compacted concrete and stabilized 2 base layers. And here is some other graphs which show asphalt pavement structure with very high thickness of asphalt in the surface. So here's some examples. We have national standards in which we have some typical pavement structures with typical pavement thickness for some design load. For example, CAD-10, that means that 10 million standard axle loads of 10 tons can pass this road during the design life. But we have a lot of different situations when we have, for example, 7.7 million axle loads, and in this, using some special design methods, we can calculate precise thicknesses of pavement structures dependent on particular pavement load, so design load. This is a short presentation from our side. We are a little bit behind the schedule, but I hope that it was interesting, and if you will have some questions, we will be happy to answer them.
Thank you so much. It was very interesting. And yeah, let me give you my presentation. First of my presentation is the can you hear me clearly? Okay.
Yes.
My first presentation is the status of expressways in South Korea and Korea Expressway Corporation. That's the contents of this presentation. This is some statistics of South Korea. Yeah, we have the 100,000 square kilometers and 41.7 million populations. Is quite a densely populated area comparing to other countries. And we have the 110,000 kilometers of length of road, and we have number of registered vehicles 23.2 millions. Our size is quite similar to the Greece in European countries. Our roads composed of the expressways, national highways, the metropolitan city roads, provincial roads, and county roads. The particularly expressways and national highways is managed by the central government, Ministry of Land and Infrastructure and Transport. And particularly expressways was managed by the Korea Expressway Corporation. Is a public company like the Autobahn in Germany and Aspinag in the Austria. Almost all expressways was built and operated and maintained by Korea Expressway Corporation, and the other areas, other lengths, you can see in the slide, 616 kilometers is the expressways built by the PPP project. That was owned by the private company, and that was managed by private company. The particular thing in Korean expressways is that almost all expressways are toll road. It means that the maintenance work, rehabilitation work was funded by toll fees by users. That's the current situation of expressways. We have 40 lines, among them 30 lines managed by Korea Expressway Corporation and 10 lines managed by private company from PPP project, and we are still in developing stage. That means that we need more high expressways and the new construction and the widening the project is is ongoing. That's the final master plan of network in South Korea. We call it a 7x9 network system. We almost have particularly expressways. In 2020, we have the 4,900 kilometers of expressways around the country. This is the KEC. It's general information. Korea Expressway Corporation have the 5,000 staff. One of the division is the R&D division. I am working for it. R&D division, R&D headquarters composed of 3 parts. One is the research institute. That is the main body. And we have 2 special centers. One is the Smart Highway Research Center. The other one is the Smart Construction Research Center. Smart Highway Research Center is for preparing the automated load, the interconnected load, or the unmanned vehicle. The other one is Smart Construction Research Center is for automation in construction works, in civil works, in roadways. Actually, we started as a small lab in 1969, and in 1989 we are certified as a public research institute for road specialized in roadways. In 2002, we established the current setup, current organization, and now we have conducted around 100 research projects every year. And that's the vision. I skip this one. This is the organization chart of research institute in Korea Expressway Corporation. We have some offices, some small divisions, Office of Environmental Research and Office of Pavement Research, Office of Transportation and ICT Fusion Technology Research, and Office of Structure and Geotechnical Research and Safety and Disaster Prevention, and corporate strategy research. This is the budget of Korea Expressway Corporation for R&D project. R&D part, the $46 million is the total budget, annual budget in R&D division in Korea Expressway Corporation. We spend the $18.63 million annually. We have around 100 research projects every year. And that's the number of staff. It's not quite big, but it's quite effective one, I think. And I can show you some facilities. You can see in the slide the main building and lab buildings and the accelerated road and environmental simulator. That's for pavement. And driving simulator, that's for the automated vehicles. And the vehicle crash test center, and we have the field test road of length 7.7 kilometers in near highways, expressway. There's some equipment we have. We have inspection robot system, mobile asphalt lab system, and noise measurement. As Professor Patico said, we have a similar one. And GPR system and region payment scanning system and FWD equipment for PMS. That's some, you can see the lab apparatus, lab equipment. The main topics of R&D for payments is the payment design guidelines. As Mr. Batikuta said, that we have our own the ME payment design guide, Korean guide. We developed that one, we applied that one, and we modified that one. And we also have conducted some research for payment material characteristics and PMS systems, payment preservation. Particularly nowadays, we are interested in low noise payment. As you can said, you said you already have that kinds of research work, and we are interested in use of new materials like GFRT, glass fiber reinforced polymer, and life cycle assessment for sustainability. And that's the global network. We have some connections, some institute around the world. That's the organizational presentation of my company. Actually, we have the Research Institute of Korea Expressway Corporation is a small one comparing to others. We have bigger one for research work for the civil engineering. Then is called the Korean Institute of the Technology of Construction. And the other important institute is the Seoul Metropolitan Research Institute for technology. That's our main research organization in South Korea. Okay. Actually, I speed up to follow the behind the schedule. Forgive me about that. This is my second presentation for modular pavement in South Korea. That's the introduction. As you know, that the prefab and the modular pavement, modular element in civil works is getting important. As the Dr. Gratulite said, the report on the future of construction pointed out three keywords in the future. One is AI, artificial intelligence, and second one is prefab and modular element in construction. The third one is eco-friendly. You can see on the right side of the McKinsey report that this kind of modular construction can reduce the construction period 20 to 50% and reduce the cost 20%. That's the common knowledge. That this slide shows the expectation for the market, global market in modular construction. The report says that Precast and modular market will increase 6.5% annually, and global market for precast concrete will increase 5.6% annually. It's quite optimistic for this field. Concerning to produce this kind of the prepare modular things, the smart factory is the necessary one. They also says that it will increase 94.7% annually. In South Korea, we have lower usage than European countries in precast element. Even in the bridge deck or in pavement field, that's why nowadays we are interested in the modular or precast, the concrete pavement. As you know, the classical construction has the obstacles: low productivity, the high risk of safety, and large impact to the environment, and any other social effect like noise and traffic restriction. Even we use the off-site construction in the roadway, we also have the another problems. If we solve the kinds of problems in classical construction, we will face another obstacles like logistics. As you know, the in roadway in civil works, the size and weight of the element is quite larger than comparing to the architectural one. That's the problem. Then makes it is inefficient in using the modular element. That was the main concern nowadays. We applied modular technologies to the roadway work. We need some technological issues, and we need some standard issues. We need some market issues. This is features of modular pavement in South Korea. We have conducted some the researches in late 1990s, and we have some pilot implementation mainly for the replacement. In the early of 2000, in taxiway pavement of airfield, it has been frequently used. They have the reason that they open to the traffic to the airplane before the dawn. They have to finish their rehabilitation work in the night time. Then makes they frequently use the modular pavement. That's the common methodology nowadays in airfield. In recent, the precast pavement is used at the bus stop area in Seoul metropolitan areas. They have planned to implement that kind of things every year, 20 or 30 project. But it is not prevailingly used in Expressway. They have some reasons. As I said in the slide, the expedite construction, electric construction, is not so important than airfield and urban roads. Yeah? And cost effectiveness is not attained. It's not difficult to attain because the limited number of panels. The cost effectiveness can be attained when you produce as many numbers of panels, but it's quite difficult in roadways. That's the obstacles nowadays we we have faced, and some regulatory issues for passage or traffic transportation, and some technical issues in the transition zone. If we place the modular pavement, we have to connect to the adjacent nearby the asphalt pavement or any other concrete pavement. So we need some technologies to connect that kind of things smoothly. Then make some problems. As the Dr. Gratulit said, that we have also the treatment of surface problems. Commonly we use the grout base as the common tools for connecting the surface and the modular pavement. These are the considerations of modular pavement. Slab thickness, that is the same one to the common the concrete pavement. There is no difference in the thickness and lifting stress. Actually, we are trying to place the modular pavement with size of the 3.6 width and 6 meters length. It's quite heavy. It means that the lifting stress is quite critical. So we need to solve that kind of problem, and if we apply some specific equipment to mitigate that kinds of critical stress, we can have some cost effectiveness in modular pavement. That's our concern. And our bar, tie bar, John, the design details, there was a concern. And the grout, the high strength mortar grout, that's commonly used. And some design details we need, and the grouting holes, lifting system, and tower tie bar pocket, the approach slab in transition zones. I show you some photos about these things, some design considerations, lifting system, and you can see some photos in the procedure of the precast concrete pavement. They have fixing nails, channels for grouting holes, and pockets. We have the various ones. The most common one is the pot-miller type. For rehabilitation, we need some site preparation. We use the GPR systems for the measure the exact thickness of distressed pavement, and we need saw cutting and anchoring and removing and base preparation. And this slide shows a recent the field work for the bus stop areas. They unloaded pavement by crane, and they positioned and grout, high strength grout, and the bottom two photos, right side, the bottom two photos, you can see the connecting the adjust the pavement to meet with the modular pavement. We used a kind of approach slab that is half height, half depth, and topped with asphalt pavement. We use this kind of system for connecting the modular pavement and the regular pavement. In some cases, when we have to fill the space, the side of the slab with asphalt, like this slide. Sometimes it makes the inconsistency that makes some problems. Nowadays, we are interested in adding values to the modular slabs. In South Korea cases, it is quite difficult to attain the cost effectiveness in modular system. As I said before, there are some reasons. So we we try to have different view about modular construction. If we can reduce the price of the modular element, we controlly we can add some values that makes the expensive one, that makes the users can pay for it. I think that there can be some functions like this: energy harvesting, de-icing, or anti-icing. The Professor article showed good examples for using geothermal geothermals for de-icing, and I think that's the important topic for adding values for the modular pavement. And the other one is condition monitoring, wheel load sensing, and smart sensing, markings, surface lightening, or the lightweight to long life that can be applied to add the values to make it expensive one, make it cost effective one. That's the conceptual one. Some of after this slide, I show you some conceptual one, hypothetical one, and some of them is implemented in South Korea, and some of them is planned to implement that kinds of things. You can see some heating for de-icing and anti-icing. You can use the solar or geothermal heating systems. And you can use the active control spraying systems that is connected to the weather station and automatic control system. And I think we can use the base change materials for heating the pavement, for de-icing, for anti-icing. And we can use the carbon nanotube for heating the pavement. Surely it is quite expensive nowadays. I believe that it is getting cheaper by developing the certain technologies in this area. And we can use the Precast system with the particular connecting system. And as the Dr. Graduate said, we have different kind of textures. We can apply different kind of textures to the modular pavement. I think that we can surely we can add some lightning or the lane markings in the modular system. I think we can do it precisely in modular pavement, precast pavement, than the classical ones. This is my conclusions. Actually, in this presentation, I don't want to discuss about detailed technologies about the modular pavement, other technologies, but I want to discuss about the future trend of the modular pavement, precast pavement. That's why I prepared this kind of contents in my presentation. This is my conclusion. It is expected to use more precast element in road construction. I believe that one, considering the digitalization, automated vehicles, and so on. Off-site construction using modular and prepared pavement can be a kind of evolution for the future road. I believe that one. The adaptability for smart sensing road is higher than conventional one when you use the prepared modular pavement. And the high productivity can be attained by prevail using of prepared modular pavement. I believe that one. And needs to develop some technology to apply the specified functions to road pavement. Okay, this is my presentation. Okay, we have some questions. In the chat window. At first, I would like us to those Precast particles about the roller compacted concrete. Do you use that one in the highways or motorways? And I think that we worry about the irregular cracking of that type of pavement. That's my concern to use that one. That's why yeah.
Okay. So thank you very much for your nice presentations. It was very interesting to get more information about the Expressway Corporation. And I remember I was actually, it was almost 10 years ago, I was attending during the IARC conference, World Road Congress, also the Institute of yours, and also some sections of roads. It was very interesting. And thank you for the good presentations. And regarding the concrete payments in general, actually we don't have a lot of concrete payments in Lithuania, as historically we are like an asphalt country, I would say. A lot of companies has own road companies has own asphalt plants, and they are very interesting to stay on asphalt, not to go to concrete. But by little, we are trying to encourage to use more concrete payments, and especially in some areas. So aprons in airfields, also some zones with very heavy vehicles, some parking lots, and with seaport container terminals, etc., etc. So dealing about roller compacted concrete, as you saw some pictures, so we more use this technology for lower quality roads or sections. And it is stated also by United States that and the guidelines which we already also use for calculation, the software, for example, street pave, etc., which comes from the United States. They see that it is not so usually proper to use for highways or very high quality roads. And we have experience in our neighbor Poland that we use roller compact concrete pavement for highway, but for this base layer. And afterwards, on that base layer, they put this joint plain concrete pavement, which is laid down by this slip form pavers. So what you mentioned about irregular cracking, yes, but this irregular cracking can be managed by sawing the joints. Dependent on the thickness, we calculate, for example, if we have 16, 17 centimeters thickness of roller compact concrete, we saw joints 4.5 meters, for example, 4 or 4.5 meters. If the thickness is less, for example, 12, 11, so for lightweight areas, it will be need to cut joints 2.5 or 3 meters, each 3 meters. But in some projects, for example, for timber squares where a lot of timber machinery goes and they store the timber, the wood, so they do not need a very aesthetic view of the pavement. And in some projects, we don't use any joints or any saw cuts for this precise dividing precisely the pavement of roller compacted concrete. So we have irregular cracking, and doesn't affect the bearing capacity of pavement structure during the locking of aggregates in mixture. So it depends on the project, and sometimes it should be cut the joints. But it's very important when we deal with the concrete. It depends on what kind of the concrete pavement it is. We have to secure when we join the concrete and asphalt, then we join some building, then we go to some curbs, because due to the thermal contraction and expansion, we have to think about that and to use some expansion joints.
Okay, thank you so much. So I have another question to Dr. Skulteke. Yeah. Which one is the prefer? Dr. Skulteke or Dr.
Now the second one.
Gradually.
Now the second one.
Second one? Gradually.
No, it's not first.
Okay, thank you so much.
Yeah, actually, I tried to change it, but it seems that every time in Zoom you have to change. So probably I have to update some settings in my profile. So sorry about it.
No problem.
Confusing information given.
Actually, the audience have some question to you. Do you have any information for the use of the modular pavement, jointed the plain concrete modular pavement in the airport around the European countries, not just the Lithuania?
In Lithuania, as it was mentioned, we don't have anything almost concrete pavements, only some sections. There are some modular concrete pavements used in New York at the international airport, and you can check this information. It's a little bit discussed in our paper, which is concrete modular pavements, types, issues, and challenges. There you will find some references, and you can go further and check all necessary information on that.
Okay. New York International Airport in USA. You mean that one?
Yes, in the New York.
Yeah, New York. Okay, it's interesting.
Just to add some comments, we deal about generally about the airport payments in Europe. So it is almost aprons is with concrete payment. If it is international big airports, all the aprons is with concrete. But the concrete is a joint plain concrete which is paid by this slip form pavers. You know, these slip form pavers which are used for German highways, Austrian highways, in Poland also. So, but there is no experience with modular payments even for rehabilitation. But you could recognize from Judith's presentation that the BAST Institute in Germany, they do a lot of research now, the possibility to use in highways the modular payment. Of course, in the beginning, it would be about the maintenance because Germany has a lot of issues because we have a lot of concrete highways from the past. Now we have to rehabilitate them, and the concrete pavement is not like that. We have a lot of problems in the very long section. So if you have the problems, one module, another module, some dowel, some key bars. So this is a very important topic now for them, and they in the past have some testing sections. But in Lithuania, even in smaller airports, we have asphalt aprons and taxiways. But now we're starting to change. For example, International Vilnius Airport, we encourage them a lot to use concrete, and they already saw the benefit of that because in the asphalt pavement we had a lot of shear rotting and some plastic deformation in asphalt there. So now they're starting to use more and more the concrete pavement in parking areas of airplanes and also in all apron areas.
Okay. Actually, in South Korea, we use the asphalt pavement in runway. The concrete pavement is frequently used in taxiway. Do you have any differences like that one in European countries?
So in Europe, it's almost all the time runway is asphalt. Runway is asphalt. We have some cases, as I saw in some warmer climate countries. It was some airports with concrete also the runway, but usually runway is asphalt, even in very big airports. And taxiways is also asphalt, and only aprons are concrete. But especially runway is asphalt due to the evenness and etc. Without any joints. We have to state that in runway we have lowest stress effect on pavement. The highest stress effect we have on taxiways and of course in people.
Okay, thank you. I actually surprised that you used the ME pavement design guide. That you don't, as far as I know, you don't have any the unified design guide in European countries. Is it right? It means that every country has their own design guide. Is it right?
Yes.
Yeah. But do you have your own ME pavement design guide? Mechanical and people?
Yeah, actually just a second. I will check. We use the you could share this typical payment structure design to show the payment structure for business will be a table. In 2009, it was approved the new document by Lithuanian Road Administration for national roads. We have this so-called typical payment structures dependent on the design load. But this document regulates that in very crowded roads, we have to use mechanistical empirical pavement design. And this mechanistical empirical pavement design can be used by, for example, approved in European Union countries. For example, we can use German one, we can use Austrian one, etc. In Lithuania, you can see the table. For example, you can see the 100 million design loads, 100, and for example, BK1 is for 1 million. And this is a thickness of asphalt. And you can see that it is some gaps, some ranges from 10 million to 32 million. And for example, if we have design load 15 million, so in some time you can have fixed payment structure, or in some cases it can be to thin. So in that cases, we use mechanistical empirical to check what would be the appropriate thickness. And we do not have like a guide for mechanistical empirical payment structure, but we developed software which was approved by Lithuanian Road Administration. And in that software, we have help, and it is included documents, some manual how to do which degradation formulas we use, etc., and what stiffness models we use for asphalt, etc. And actually, it is also in English version, and you can use that software too. So it is called Struktura, and I will try to and it is web-based software. It is not like that you have to install. You just go to the page and you register your name, your email address, and you get permission to use that program. So if you would like, you can try. Your institute colleagues can try that software and to compare the results of calculation by your mechanistical empirical and this software. So we will send you the link to how to connect to that software. Okay.
That sounds great. Thank you so much.
Yeah,
I have another question too.
This is online. And this is online.
Okay, great. I have another question to the Dr. Skulteke. Do you have the particular design method for determining the thickness for modular pavement that is different from conventional one? Actually, in South Korea, we have the same one. in determining the thickness of modular pavement?
So we do not have any specific programs, and as I know, in Europe there are no this kind of procedures. Typically, these kind of pavements are designed with typical procedures that are used for the jointed concrete pavements, and it is recommended to use the Ashtover, the last version, Mechanical Empirical Pavement Design Guide, because it's developed to calculate the thickness for both asphalt pavements and concrete pavements, and it is believed that it's one of the best tools. And I'd also like to mention that there is a very good manual for jointed precast concrete pavement by Smith. So if you are not familiar with it, I can also share. It's free, and you can find it online on the website.
Can I understand what you're saying, that there is no difference between conventional one, common one, and modular one in determining thickness?
Yes, the main question is how to ensure the transfer between adjacent slabs.
Okay, thank you. There is another question to you from audience. You said that 3 different kinds of the surveys. One is the grading, and the second one is grouting. The third one is the files or beams or the concrete, like body slab. What is your expectation for the use of 3 kinds of things? Which one is most popular, becoming popular, do you think?
So the most popular is the grade. When you are putting the slabs on the aggregate on the layer of aggregates. I saw that there was also a question related to the cement treated base. So this base can be also used, but it's typically prevented because you need to closure the traffic for longer time, because you need to do additional works. That's why the most convenient and would say the fastest way to construct modular pavements is to do it on the unbound base, on the granule base.
Okay. What? Actually, I have the body slab 10 years ago, but I think I cannot find any other further researches about it. Do any trends about it?
No, we actually, the same situation, we do not get any other additional information afterwards.
Okay.
Yeah, and just to mention that is this principle which we use in roller compact concrete with stabilized soil, subbase and base, it would be also very beneficial for this modular pavement too.
Okay.
And I saw
as a subbase.
Yeah, as a subbase and base, even base. And I saw that you have research projects about soil stabilization. So it is also very, very interesting what you get, what is the results of that research. And we have a lot of research with soil stabilization for pavement subbase and base layers. So changing aggregate material, this is very, very costly. And to use stabilization instead of introduction of new material.
Okay, thank you. Okay, let me check the chatting window. Is there any other questions? I can take the questions from audience. Actually, I'm not the quite a specialist in modular pavement. Dr. Ho, one of the audience, is the TC chairs of the precast concrete pavement in South Korea. is specialized in precast concrete pavement. Dr. Ho, do you have any comments or questions?
Hello, I'm Hanjin Oh.
You can say in Korean.
이 세부적인 궁금한 것들이 좀 있는데 그 사이즈를 두께도 그렇지만은 사이즈를 패널의 사이즈를 정한 그런 뭐 가이드 같은 게 있었는지. 일단은 우리나라는 기존 JCP 크기를 준용해서 가는 게 있어서 이제 4m, 6m의 크기를 쓰고 있는데 크기가 작아진 게 조금 좋아 보이더라고요. 그런데 크기가 작으면서 발생할 수 있는 줄눈의 개수가 많아진다든지 그런 것들이 같이 연계가 되는데 그래서 크기를 결정하는 뭐 가이드가 있는지 그게 좀 궁금했습니다.
Okay, let me translate it. He curious about the lengths of modular pavement, precast pavement. They are quite different from site to site and project to project, from 1.5 meters to 60 meters, like in South Korea. Is there any criteria or is there any procedures to set up the lengths of modular pavement? Do you think?
So yeah, thank you for the question. And general criteria is the width of lane. For example, if we talk about the pedestrian pathway, so every time it will be the width, it will be the whole width of the pathway. For example, if we design a 2.5 meters width of the pathway, so we try to keep with this width of the slab. And if we deal about the roads or highways, so every time we want to have a slab not less than the width of one traffic lane. So this is for cross section. If we go to longitudinal direction, so this is the main thing is the weight of the slab, and yes, and the gabarit to transfer the slab to on site. And of course, we cannot make a very long slab, for example, 15 meters, due to the this thermal expansion and contraction. So in general, it depends on the thickness of the slab and on the design, what was designed in the project, the fits, etc.
Okay, it makes sense. Okay.
Okay, and I have one question. It's more like regarding your research project reports. So these reports are like a public in your country. Everyone can get familiar with them, or it stays like in the company or in some defined organizations.
I'm sorry, pardon me. Your speaking is howling a little.
You presented that you have a lot of research projects. Yes, research activities, and when you did some research, you get the report of that research. There's some conclusions. You have the document, yes, finally, that you find out something, what you did and what you find out.
Okay, we have some.
These reports are public. Everyone can get those reports to read them or no.
I'm not sure I understand exactly, but we have some web system. We uploaded every report, finished one, and it should be implemented in most cases in the field. And Dr. Skuteke, would you explain again that his voice is howling? That I'm sorry about it.
Okay,
Yeah.
sorry.
So the question is that we are interested if you have if your reports are available to the whole society, if everyone can read them, or is it is it like they are ordered by private companies and it's like the company secret and etc. So we are interested if we could become familiar with your research results.
Okay, sounds great. Actually, we have, as I said, we are public company. It means that we always open to the public the research result. We uploaded every research result on the website that is published on the website, and that is open to public every time, everywhere. But unfortunately, that is in Korean. and the Korea, South Korea is the far east of the Asia. It means that it is quite difficult to communicate to the foreign expert like you, and the language barrier also the problem. But our report open to public every time.
Actually, I was surprised that Google translates it very well.
Okay. Is there any other questions from audience? Okay. I think we can have the other chance to have this kind of discussions. I guess this is a good start. So much.
Thank you very much, and we will check also your website, and maybe we will introduce some additional questions, and of course we can discuss later on. Thank you very much.
Thank you so much. I appreciate that. If my audience have also the questions to you, I forward them to you later. Okay.
We will send you the link to the Via Structura program to make calculations with mechanistical empirical.
Okay, thank you so much. Thank you. Let's level this meeting. Thank you. Great.
Thank you.
Thank you.
Thank you.
Thank you. Bye.
Bye.
Thank you.